Men, and I use the term loosely. Good morning. I wasn't going to do a video like right now, but I'm taking this cylinder head apart, and this is one of my cylinder heads I got on my project bike, and it's one of the heads I took off and was surprised to see the guy had just done a valve job on it. It's never been run. And people talk about valve guide seals on Harleys and good idea, bad idea. Well, here's a good example as to why it's a bad idea. This is all the space there is between the valve and the upper spring collar. This collar is going to hit this seal and start breaking it up, okay? It doesn't do any good to just machine down the top of the guide, because this shoulder on the lower spring collar keeps the valve seal from going down far enough. So to make this work, you'd have to machine this lip off of the lower collar. Then there might be enough room. There's different seals out there, and I'm not sure which is which on this, but you'd have to shop around for the shortest possible seal, because you want there to be more space between the upper collar and the seal. So this ain't going to work, and the collar is going to come down, it's going to hit this, it's going to start smashing it up, and it's going to destroy it, and little pieces of rubber and little pieces of metal are going to be circulating through your motor. So this is why some guys don't use seals. I don't. The bikes came without them. I really don't believe they're necessary. But if you do think they're necessary, you need to put a little more thought into it than just popping a seal over the guide, because this is not going to work. So here's the subject of the actual video today. I got two heads over here. The one on the right is the head going on my 74 XLCH Custom. The one on the left is a practice head I just practice things on. But anyway, we're going to look at these two heads. You might be able to see the faint outline of this boss cast into the practice head. I'm going to take the real head, the head I'm using, and I'm going to cut through that boss with the Makita out in the dirty shop. Then I'm going to smack it right here with the hammer, and it's going to break off, hopefully cleanly, right behind the boss there. Then this fin right behind the area I break off needs to get removed too. So I'm going to smack it with the hammer, and hopefully it'll break cleanly off too. So the first order of business is breaking the head. I always feel bad about it, but hey, you can't make a cake without breaking eggs, and you can't dual plug a head without breaking fins. So I'm going to take this outside and hit it with the Makita and get ready to break this fin off. It's raining outside. I usually do all my metal cutting outside to try to minimize the mess in the shop. But anyway, it's raining outside, so I'm not going to set the camera up. I'm not going to video it because it's raining, and we're going to go cut it quick and get back to working on it. Yeah, I've cut that boss up to around this area, as deep as the cut-off wheel will go. I always feel so bad about this. It just doesn't seem right. And there you go. You really couldn't get a nicer result than that. Yeah, hopefully the bike doesn't need this part. And this fin has got to go, because that spark plug ends up right in here. And there goes the other one. Yeah, ouch. So here are the two heads. At this point, well, I just got back from outside and I used a carbide and a flap disc to clean this all up in here a little bit so I didn't have so many shards sticking out. At this point, the head is still a regular head, minus a few cooling fins, of course. but it's still a head. The next step is to drill the holes in here. And you may ask, how in the am I going to do that and get it in the right spot? Well, I'll tell you. I have, of course, a jig. I did a video many, many moons ago about the whole process of making a jig and all that. But I'll give you the short version. The short version is this. I made a bushing that fits in a spark plug hole with a hole in the middle for a drill. I then bolted this chunk of steel to the head and drilled from the outside in. And that established probably this hole over here. And once that hole was established, you could turn the jig around and now bore, well, through the outside of this, but the inside of the head and out. And that's all there is to it. Do you have to do it that way? No. I suppose a guy could eyeball it. You know, there's a spark plug on the other side. You probably could eyeball it. Conceivably, you could do it by hand without any machining tools. And I will drill this hole with the 3/8 inch drill by hand, just because it's easier. But yeah, anyway, so we're going to drill some holes in this thing, in both of these. And of course, once you've drilled a hole in the head, you're committed. Right now, I'm not actually really committed. I've just cut a couple of fins off and call it stupid or whatever. But yeah, after I drill the holes, obviously committed. So we're going to drill some holes in them, and I guess I'm going to be committed. Well, I guess I'm ready to drill the hole. So let's drill a hole. Of course, you can't see in there. Doesn't seem like it's cutting real well. Well, there's chips in the ports. There's chips in the other port, so it must be cutting. Let's carry on and see how it goes. It's cutting. Yes, we're through. So the spark plug is going to go here. The hardest part of this operation is facing this off to get a flat surface for the spark plug to seat on. And that's going to get done out on the mill. I'm just going to run a 3/8 inch drill down through the hole. Then we're going to take it out to the mill. When I get it out on the mill, I'm going to put a 3/8 inch rod in here and use this to center up under the mill head so I could spot face this, tap drill it and tap it. Anyway, that alignment needs to be precise. The tap drill and the spot face and the tapping all needs to be very precise. This works so far, not so much. All right, I'm going to tell you how I do the dual plug setup on a head. I have the same angle plate that I use for doing a valve seat pockets. I have a fixture plate over here. This one is different than the one I use for the valve seat pockets. This one is set up for the dual plug, so it's a little bit different. The angle, obviously this angle could be adjusted on this angle plate. I have a machinist jack I try to get underneath there one side or the other that helps me precisely maneuver it up and down. The angle could also be off because it's rotated one way or the other. I use head bolts to fixture the head to this fixture plate. Well, the head bolts are a little bit, I'm not going to say snug, but there's not a lot of free play that allows the head to be twisted very much if the angle's off.
any appreciable amount. So I have some head bolts that I neck down. So when I put the head on with these, I've got room to maneuver the head around the neck down part of the bolt. So let's throw a head on the fixture. I use 2 bolts. I think that's all you really need. Okay, the head is just barely snug. We're going to set this angle first. This is a 3/8 inch rod. Nothing special about it. This is the same device I use for doing the seat pockets. Square steel bar, precision hole drilled in it so that it fits very nicely on this rod. I got my digital angle indicator. It's zeroed on the mill table. Stick it to the square bar with the hole in the middle. I use this machinist jack to precisely set the angle on the angle plate. Right now, that's where I want it to be. We're going to tighten it down, and I shouldn't have to touch it again. For the duration of this operation. Ouch, damn it. Okay, that's pretty tight. It ain't going anywhere. All right, the angle is off in this direction. So because I've got the head bolts neck down, I've got room to rotate them around and get them where I want them. Okay, I'm bleeding. The pilot hole for the plug is now vertical in the mill. What I have to do now is center this pilot under the mill. It's vertical, but it's not centered. Oh, look at that. Well, that's going right in there. Okay, good. Once I've got it that close, I slightly loosen the angle plate and a toe clamp. This can now rotate around a little bit. A little bit, not much. I put a couple of drops of oil on my pilot. I turn the mill on. Okay, the head is bolted securely to the fixture. The fixture is bolted securely to the mill table. The pilot for the spark plug hole is centered under the mill. The device I use to do the centering is the driver, the same driver I use for the valve seat pockets. It happens to be 3/8. This is a 3/8 pilot, so that's the arrangement I use. Now I get this out of the way, and I get this out of the way, and we're going to put a counter boring tool in here and mill the seat for the spark plug. What I got here is a counter boring tool piloted. This is a Morse Taper 3, and it goes into a Morse Taper 3 to R5 adapter. There's probably other ways I could do this. There's a big hump over here, where the fin was broken off. End mills in the milling machine do not like that. This usually works pretty good. We're going to see. Okay, you'll notice the pilot glides right into the pilot hole, dead nut center. So the setup is good. So I'm going to do this by hand. I got 95 RPM dialed in. Let's see how it works. Like I say, this big lump over here where I broke the fin off, the milling machine and the end mills don't like that at all. In case I forgot to mention, which I think I did forget to mention, the X and the Y are locked down, the column is locked down, and I zeroed out the DRO. So if I had to move this thing for some reason, theoretically I just bring it back to the zero on the DRO and it should be good to go. I'm going to stop every so often and suck the chips out so I could see how far I've gone and how far I have to go. Things are going well. The machinery is not complaining. All right, I'm setting the depth by eyeball. I fiddle-futzed around with the other one by trial and error to get the spark plug depth the way I wanted it to be. So this one I'm just trying to make look the same as the other one. You want the spark plug to be below the inside surface of the head. If it sticks out beyond the surface of the head, it will hit the piston and it will f things up. So anyway, it looks like I got a little farther to go comparing it to the other head. I'm going to go a little deeper. All right, looks like we're right there. So the next step is to drill out the spark plug hole to the tap drill size. All right, I got the tap drill chucked up, so let's go for it. That's done. Next step, let's tap the threads for the spark plug. This was a good tap. It was an expensive tap, and I've said it before. Good taps make all the difference in the world. This thing cuts great. Okay, the tap is all the way through. We'll do a test fit. Very good. The next step in this process is to put the clearance notch in the rocker box. All right, we got to mill a pocket in here for the spark plug to clear. And I'm going to break machining rules. I got an end mill chucked up in a drill chuck. And I hear you're not supposed to do that. But that's what I'm going to do. Okay, the mill did not like it when I tried to do the whole inch at one time. So we're taking it up in steps. And why am I using the drill chuck instead of a collet? Because I'm lazy. All right, now I got to switch to a collet because the mills get too large to fit in the chuck. Whoops, hit the down limit switch. This line right here, if you could see it, is where the oil passageway is drilled through the rocker box. I've got to stay on the bottom side of that. And that should be the last operation on that. Let's suck the chips out of there. Let's put a spark plug in there. Yeah, you're probably looking at the back of my hand. Oh well. And let's put a boot on the spark plug. And there you go. It'll work. A socket won't fit unless I take more metal out of the rocker box, which I don't feel like doing. I don't know. No, I'm not going to. So I may have to grind a box end wrench or something to get the plug in and out of there. But happy with the way the wire fits and the amount of clearance there is, so that should work good. So the uninitiated might think we're done. Not quite. We're going to pull this off of the fixture and take a look at the spark plug protrusion or lack thereof. Now, in case it's not enough, I haven't moved the table. Well, if I did, it wouldn't matter because I've got the 0 set on the DRO. So theoretically, bolt this back in here, check the angles, and it should line up. Just about perfect. I'm going to go in there with a 9/16 drill and clean out the bottom 3 or 4 threads because they don't need to be there. And I'm going to put a little chamfer on that hole so that there's unobstructed flame path to the combustion mixture, I guess is what I would say. So yeah, this one is almost done. I just lined this up by eyeball. Well, flip the head around and line this up by eyeball. I just want to take like 3 threads out of there. I want to put a plug in there and see how it lines up with the end of the threads. And that is perfect. We'll get this drill bit out of the way. We'll put this countersink in there. And we're going to chamfer that hole just a little bit. Yeah, a little bit more maybe. And we're going to call that good to go. This head is done. So here's the end product of my toils today. The extra plug hole installed, the notches cut in the rocker boxes to clear the spark plug. Very happy with this. So we're going to move on. Not sure what's next up for tomorrow, but whatever it is, we'll figure it out. And with that, I am out of here. Thank you all for watching ever so much. We'll see you next time. Bye. Men, if you like this channel and this content, the single most important thing you could do to help grow this channel is to hit the subscribe button. I also have new design coffee cups and stickers available. You know, I like the old coffee cups, but I like these new ones even more. Links are included in the description down below. And for those of you who really want to go the extra mile, you could join me on Patreon. Link is also included in the description down below. And to all of you who have watched these videos, I'd like to say thank you. Thank you very much. I really, really do appreciate it. We'll see you next time. Bye.